Hey, welcome to the video where we're going to be just really identifying and defining different types of angles. And a lot of them are going to seem really familiar from elementary school. So the first part of this video is just going to be a quick, brief review, and then we'll kind of start to talk about some of the relationships, the newer relationships between angles for this school year. First, the three that you definitely know are going to be acute, obtuse, and right. Friendly reminder that the acute angles are angles that measure less than 90 degrees. And I want to point out that here we can use the inequality symbols to show that the measure of the angle has to be less than 90. That's what makes it acute. But also it has to be bigger than 0 degrees. I mean, it has to actually be an angle. So here's an inequality way of writing that for the measure of the angle has to be between 0 degrees and 90 degrees. You guys also know that obtuse is something that is more than 90 degrees, which again means that it has to be greater than the 90, which is what I'm showing here, but less than 180, and I'm going to talk about 180 in a second down here for being a straight angle. But yeah, so you guys know about obtuse being more than 90, and then for right, it's the one that's exactly 90 degrees, so the measure of the angle equals exactly the 90 degrees. So that's a pretty basic, easy review. This just might be kind of a newer 7th grade way right here of writing what the acute and obtuse angles have to be. So now let's just review real quick what a straight line is. So a straight line measures exactly 180 degrees, exactly 180. And here is a picture of it up here. And I want to use this blue arrow that I have right here in my circle. I have a diameter cutting all the way across my circle. And if I take this blue arrow and kind of move it up like that, that creates that 90-degree angle that we just reviewed a second ago. So here you have a 90-degree angle, and I can kind of draw it in for you. Let me get a pen tool. So here is a 90-degree angle, but then also on this side is another 90-degree angle. So if I take my blue arrow, that 90 plus this 90, that's the 180. And I could do plus another 90 and be at 270, and then plus another 90, and that's 360. So a full circle going all the way around is going to be 360. And a straight line right there, that's going to be the 180 degrees. I'm going to leave it up at 90 though, just for the picture, just so you can see the two 90-degree angles. Now, if you have two angles who add up to form a right angle, that's something called complementary. I think that this is going to be a new word for a lot of you this school year, complementary, adding up to 90. And even though it's spelled a little bit different, I want you guys to just think about, like, if you are walking down the hallway and you see somebody wearing a shirt that you like, or that they got a new haircut or something, and you want to give them a compliment, we all love getting compliments. It's always going to make somebody's day if you just say something nice to them. So you can kind of think about how it's the right thing to compliment someone, and I can write that in here. It's the right thing. Now, even though, like I said, that's spelled with an I, like when you give somebody a compliment, but that's just a way to think about how the 90 degrees, the complement, that's the right angle is the 90 degrees. Now, supplementary is when it adds up to 180. Okay, so supplementary is when they make a straight line. So in this unit, we're going to look at angles that either add up to make a right angle, or they're going to add up to form a straight line. Okay, and that's what I said right there, highlighted in that pinkish purple color. Now let me give you just an example of what we're talking about here. If I say that angle Y up here, if I say that this is a 30-degree angle, so if this thing measures 30 degrees, well then this thing has to be 60 degrees, because 30 plus 60 is going to give me that 90-degree right angle. So if that was 30, what I mean by complementary is that that has to be 60 to add up to be 90. Okay? So that part wasn't in your notes right there. I just added that here for the video. That if Y is 30 degrees, then X has to be 60. Okay. Now over here, to just kind of give you an idea of what I mean by they add up to 180. So let's say in this example, the measure of this angle Y right here, let's say that I say that that's a 45-degree angle. And so if that's 45 degrees and I want it to combine with this one to make the straight line of 180, then you would just do 180 minus the 45, which is going to be 135 degrees. Okay. So X up here is obtuse, Y is acute, and together the relationship between them is that they form a 180 degree straight line. So these would be considered supplementary angles. Over here again to review, X and Y add up to form a 90-degree angle, so those are considered complementary angles. All right, now let's flip over. And in this picture that you guys see up here at the top of the next page, I've actually got two lines A and B, which are parallel lines. And if you want to mark them as A and B now, now's a good time to do that. And I have a line cutting across them. And that line cutting across my two parallel lines is called a transversal. This might seem a little like the word transcontinental that you've heard in history. The Transcontinental Railroad cuts across the United States. So think about that when you're remembering that a transversal cuts across two or more parallel lines. Now, the reason it says two or more parallel lines is because, for example, I could put another line that's parallel to A and B right there, and the transversal is still cutting across that line as well. I'm going to delete that line though now because I don't need it for the rest of the notes. So line C here is called a transversal, and I'll put that right here. We're talking about line C for the transversal, okay? Now, congruent is a way of saying equal, but we're just talking about like how angles measure the same or how two line segments could have the same measurement. So when we say it in the equations unit, we say like 5 equals 5. But in this unit, we would say that a 90-degree angle is congruent to another 90-degree angle. And the symbol that you see highlighted right here, that's my symbol for congruent. And we're going to see that down here in a problem in a second. So I just wanted to point out that when we're talking about two angles equaling each other, you'll just see that symbol. It's an equal sign with like a little kind of squiggle on top of it. That's how I would write it out. Now, to give you an example of what I mean by congruent, over here, this angle right here is the same as this angle. They have the same angle measure. Whatever this angle measure is, we could see right here it measures the same as angle 5. Another example of things that would be congruent, for example, if I took this angle 2 and kind of traced it right there with my purple marker, see how if I move that down, it's the same as angle 6. So 2 and 6 are congruent. They definitely have the same measure. I could even take it and turn it around, and we could see that it's the same there as angle 4. So 2 and 4, I would say, are congruent, okay? So 1 and 3, those look congruent. And to prove it again, let me just get a green marker out. Let me trace angle 1. And now if I take angle 1, again, there it is congruent to angle 5. And if I turn it around, right there is 1 and 3 being congruent, okay? All right, cool. So now we've got a good idea of what congruent means and how to find congruent angles in a picture. All right, let me erase this. Now let's talk about what adjacent means, okay, adjacent. Now adjacent, most of you have heard that in the context of it being next to something, and that's still going to work here. You can think of adjacent angles as being next to each other, but just make sure that they share a common ray, okay? What I mean by that is that over here in this picture, angle VJK is next to this angle LJK, and it shares this ray. I'll highlight it. It shares this ray. You might remember that a ray has an endpoint and then an arrow that goes on in another direction. So I can now say that these two angles are adjacent because if I were to trace both of them, they both trace that line. And that's how you know you've got adjacent angles, all right? So looking at the picture up top, let's use this image. We're going to use this image with parallel lines A and B and the transversal C to just identify adjacent angles, okay? So up here, angle 1 is actually adjacent to two different things. If I trace angle 2, it's adjacent. I could also trace angle 4, and it would share a ray right there. So both angles 2 and 4 are adjacent to angle 1. So angle 1 is adjacent to angle 2 and to angle 4. Now, it might look a little bit like a less than sign. I just want to point that out when I write it, just because the way I write on the computer marker, it's a little weird. But notice that the angle symbol is really meant to be more like that versus a less than inequality symbol looks kind of like that. When it's typed, it really stands out, but when I write it, I know it might look like an inequality symbol, but just know that I mean an angle, okay? All right, now angle 8. So angle 8 right here is next to angle 5 and next to angle 7. So next to angle 5, and then it's also adjacent to angle 7. All right, now 2 up here, we already know is adjacent to angle 1, and then now it's also adjacent to angle 3. And if I use this picture over here, LJK, and so LJK is going to be adjacent to KJV. So angle KJV. Angles can be measured, or marked, I should say. They can be marked with numbers like this over here. Or if there's letters, you would say like angle LJK for this guy. And if you said KJV, you're talking about that angle, that 80-degree angle right there. All right, now let's look at this multiple choice problem underneath this picture. Let's see what it says and see if we can decide on our answer. So what this reads right here is if the measure of angle LJK is congruent to the measure of angle KJV, so basically we're saying that this right here is congruent to this right here. They are the same measure. Then what is KJL? So KJL must also be 80 degrees. Notice that they're not quite forming a straight line. This ray right here needs to come down a little bit for this to form a straight line. Right now I'm at 160 degrees total, and it would need to come down a little bit more for that to form like a straight line. So it's not asking about supplementary. I didn't want you to get confused about what we discussed on the other page. It's just asking if they're congruent. It's just asking if you know what the word congruent means. And it's asking if you know how you can read it in the language of algebra. So we're going to pick letter B right here for 80 degrees. And we're going to move on. So this is us getting really comfortable with how to find adjacent and what congruent means. Now let's talk about something called the vertical angles. And when I talk about vertical angles, I really want you to just think about a bow tie. So in the picture over here, let me draw the vertical angles. Angle 1 is vertical to angle 3. And you can kind of see right here that it almost looks like a bow tie. So vertical angles, they're congruent. They have the same measure. And they're across from each other at an intersection. Okay? So if we fill in some right here, let's just practice identifying. So 2 makes a bow tie kind of looking thing with angle 4. So 2 and 4 are vertical. All right, 5 and 7 are vertical. We already identified up here in blue that angle 1 and angle 3 are vertical. And last but not least, angle 8 is vertical to angle 6. All right? So as you're taking notes, just make sure you've got the definitions written down, and then just write down the answers as we're going through how to identify the different vertical angles. All right, and now let's talk about corresponding. Now, corresponding are one of the tougher ones for students to remember. Just so you know, I kind of want you guys to remember that this, for whatever reason, every year, this is one of the ones that students kind of forget even exist. So corresponding, I really like corresponding. Let me get a highlighter out for these. So corresponding, they're actually just in the same spot, but at a different intersection. So let's first look at angle 1. So angle 1 is in this spot at this intersection. All right. So now I want the angle that's in the same spot, but just at the other intersection. So that's going to be angle 5. And again, these two angles are the same measure. They're congruent. If I drag this down, you can see it's the same. So angles 1 and angle 5 are corresponding. And they are also technically congruent, which is what it says right there. They're congruent angles. And they're just going to be in the same spot, just at a different intersection. So now let's look at angle 2. So angle 2 right here is down here. It's angle 6 now. And again, I just really like proving that they're going to have the same measure. If I kind of trace that angle right there with the blue highlighter, again, I can prove that it's congruent. You see, it's literally the same angle. And it's just in the same spot now down here at this intersection. So again, we've got corresponding. All right, 3. So angle 3 is right here, kind of on the bottom left corner. So we want bottom left corner of this intersection, so angle 7. And angle 4 is right here, and so that's going to match up with angle 8 right there in the same spot, just at the other intersection. So like I mentioned, y'all, the first page, you mostly knew about these angles like one individual angle on its own in elementary school. And you're starting to learn about the relationship between types of angles. If they add up to 90, they're complementary. If they add up to 180, they're supplementary. If they are next to each other, we call them adjacent. If they are across from each other, they're vertical. And if they're in the same spot but just at a different intersection, they're called corresponding. Now when we flip over, we still have 2 more types to identify right here. And I love highlighting the parallel lines here and here to kind of help you see that this would be what's inside my green parallel lines. The yellow part up in here is considered the interior. So the interior angles, my interior angles are actually 3, 4, 5, and 6. 3, 4, 5, and 6 are all on the interior. Now what do I mean by alternate interior? I mean that they alternate around the transversal. So if 3 is on this side, it is alternate interior with angle 5 on this side. And it really helps a lot of students to kind of see the Z. 3 is on the inside of the parallel lines, and so is angle 5. And see how they're on opposite sides of the transversal here? So angle 3 and angle 5 are alternate interior, while 4 is alternate interior angle 6. Now while you guys are taking those notes, if I highlight again my green parallel lines, now I'm going to highlight what's considered on the outside the exterior. So you've got the above exterior and then the below kind of outer exterior here, which means the exterior angles are going to be angles 1 and 2. Angles 1 and 2 are exterior, and angles 7 and 8 are also exterior. Now what do I mean by alternate exterior? Again, same concept. They just alternate around that transversal line right there. So 1, alternate exterior with 7. 1 and angle 7 are on opposite sides of the transversal. And again, it's really helpful to kind of see that and that. There they are. And then we've got angle 2 up here, alternate on the outside with angle 8 down here, angle 8. So alternate interior and alternate exterior angles, both of them, what they have in common is that they kind of alternate around the transversal, but interior means that they would be on the inner part here versus exterior means that they would be on the outer part. So what you're going to do now is you're actually going to just practice identifying. You've got some problems here down below on the rest of this page, and the answers will be going into a Google form. And then there's 2 more questions over here on page 4. And so yes, you're getting ready to, when you're done with the video, you're getting ready to fill these out. But before I turn you over to practice on your own, I just want to mention real quick that if I say that this straight line right here makes 180, and to me this is clearly an obtuse angle, and I'm going to say that this thing measures 100 degrees. If this angle measures 100 degrees, it is vertical down here. That means this one also has to measure 100 degrees. And since this one right here and this one right here form a straight line, I know that this has to be the 80-degree angle. And I can also prove then that this is 80 because vertical angles are congruent. You can see I even have the little bow tie looking thing here in the problem for you. So those have to be the same. And then these also have to be the same. And then if you really look at this all the way through, I'm making a circle. And you can see if you add up the 180 and the 180, that's going to be the 360 total. All right, that now concludes this video. Don't forget to fill out the Google form when you get done answering all the questions on pages 3 and 4. Thank you for watching.